welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to make an effort to review all the topics from algebra that you have to understand in order to be successful on the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the PiCAT. More specifically, I'm going to be covering all these topics here. In total, there are 14 of them. In total, these topics account for about 50 to 60% of what you'll see in the mathematics knowledge subtest of the ASVAB. So it behooves you, in other words, to really make an effort to understand each and every one of these topics. Now, let me say this. This video is a general review of these topics. So if at any point you struggle with any of the problems in any of these topics, just bear in mind that I have videos for all these topics on my YouTube channel. As a matter of fact, in the description of this video, I'm going to include links to each of these topics. So if as you watch this video, you get stuck on solving system of equations, go to the description and then click the link there, which will guide you to my video on solving system of equations. So all that being said, let's go ahead and get started with today's video. All right, so let's get started with our first topic. As you can see, it's in regard to combining like terms. And before we look at question 1, let me say this. We identify like terms using this definition. We say a pair of terms are like terms if and only if they have the same letter variables and they're raised to the same powers. Again, like terms have the same letter variables raised to the same powers. So with that in mind, let's take a look at this first question. So I'm going to start by writing this down as if I was writing on my own scratch paper. Again, we have 3x plus 2xy plus 2y plus 4x plus 7xy minus y. All right, our goal here is to combine all the like terms in this expression, which will simplify this expression. So typically, I like to start on the very left-hand side of the expression and work my way to the right. So that means I'm going to start right here at 3x. Again, we have the letter variable x, and as it happens, it's raised to the first power. In algebra, you typically don't express powers of 1. So we have to know that this is x raised to the first power. So let's scan through this expression and see where else we have the letter variable x raised to the first power. And as we can see, that's right here. So 3x and 4x are like terms, and therefore we can combine them. 3x plus 4x is 7x. And once you combine your like terms, it's a good idea to go ahead and cross them out from your expression. All right, moving on, we have 2xy. That is to say, we have the letter variable x raised to the first power, as well as the letter variable y raised to the first power. And if we scan the rest of this expression, you can see that its like term is right here, since we have x to the first power and y to the first power. So in light of that, we can add 2xy and 7xy together, and that becomes plus 9xy. And now that we've combined them, we can go ahead and cross them out accordingly. And then finally, we have 2y, which has the letter variable y raised to the first power. And if we scan our expression, you can see that its like term is right here. Again, this is y raised to the first power. 2y minus y is just y. And let's go ahead and cross those out, of course. And just like that, we combine all the like terms in this expression, and that gave us the answer of 7x plus 9xy plus y. All right, let's go ahead and move on to number 2 here. All right, so as you can see, number 2 says 7 over 16x plus 1 over 8x. And the big question is, are these like terms? Well, again, when we talk about like terms, we focus on the letter variable and the power. And in 7 over 16x, we have the letter variable x raised to the first power. And in 1 over 8x, we have the letter variable x. And of course, that's raised to the first power. Given that these both have the same letter variables raised to the same powers, we can say with confidence that they are like terms, and therefore we can combine them. So we're going to combine 7 over 16x with 1 over 8x. Now, here's the tricky part of this problem. Our coefficients, notably 7 over 16 and 1 over 8, are fractions. And in order to add fractions, they have to have the same denominators. So we have to find a common denominator between 16 and 8. Well, we should realize that 8 and 16 both go into 16. So we're either going to rewrite one or both of these such that they have denominators of 16. And as you should see, 7 over 16 already has a denominator of 16. So we're just going to copy that one down as is. But that said, in order to write 8 as 16, we have to multiply it by 2. Again, 8 times 2 is 16. And to keep proportionality, we're also going to have to do that to its numerator. 2 times 1 is 2. So this becomes 7 over 16x plus 2 over 16x, which is 9 over 16x. All right, so when we combine the like terms, 7 over 16x plus 1 over 8x, our result is 9 over 16x. All right, let's take a look at a third example of combining like terms. Again, when we talk about like terms, we're focusing on the letter variable as well as the power to which that letter variable is raised. So let's go ahead and copy this one down to start. Again, we have 2x squared plus 5 minus 4x to the third plus 7x to the third minus x squared. And I like to start on the very left-hand side of my expression. So I'm going to start right here. Again, we have the letter variable x raised to the second power. And if we look through this expression, we can see that its corresponding like term is right there. Again, we have x raised to the second power. Therefore, I can combine 2x squared and negative x squared. 2x squared minus x squared is simply just x squared. And now that we combine those, we can cross them out. Next, we have we just have 5, which is a whole number, and there's no other whole numbers in this expression. So for the time being, I'm just going to copy down that 5, then I'm going to cross it out. Finally, we have negative 4x to the third. That is to say, we have the letter variable x raised to the third power, and we should recognize by now that 7x to the third power is its corresponding like term. Therefore, we can combine these two. Again, I would read this as 7x to the third minus 4x to the third. So that's going to be plus 3x to the third. Now, we aren't done in this problem because typically you write expressions such that the highest power comes first. Of course, our highest power is 3, followed by 2, and then followed by our whole number. So this is going to be written as 3x to the third plus x squared plus 5. And now we are done with that one. All right, so that's all there is to combining like terms. Let's go ahead and move on to something that's slightly more challenging. That is, let's take a look at how we're going to add and subtract polynomials. All right, so as far as adding polynomials goes, it's the same thing as just combining like terms. And given how identical those two processes are, let's go ahead and take a look at this first question. It says add 2x squared plus 6x plus 5 and 3x squared minus 2x minus 1. In case you haven't worked with polynomials in a long time, let me just say this. This 2x squared plus 6x plus 5 is one of our polynomials, and this 3x squared minus 2x minus 1 is another one of our polynomials. All right, and we're just adding these two together, so let's go ahead and do that. This becomes 2x squared plus 6x plus 5 plus 3x squared minus 2x minus 1. Again, all we're going to do is look through our expression and combine our like terms. So I'm going to start all the way on the left here. Again, we have the letter variable x raised to the second power. And if we look through the expression, we can see that its other like term is right there. So we can add 2x squared and 3x squared to be 5x squared. And now that we've combined them, we can go ahead and cross those terms out. Moving on, we have 6x, that is to say we have x raised to the first power, and its corresponding like term is right there. Again, negative 2x, we have x raised to the first power. 6x minus 2x is 4x. So let's go ahead and cross those out. And then finally, we have 5 minus 1, which is just 4. All right, so that's all there is to adding polynomials. It's pretty simple and straightforward. Generally, people have no problems adding polynomials. That said, a lot of people struggle when they have to subtract two polynomials. And let me show you why. Again, number 2 says, subtract 2y squared plus 2xy minus 3 from 5y squared plus 2xy minus 3. Again, here's one of our polynomials, and here's another one of our polynomials. So in essence, we're subtracting this polynomial from this polynomial, which looks like this, 2 minus 1, okay? So let's go ahead and get this one set up. Okay, we have 5y squared plus 2xy minus 3. And from that, we're subtracting this polynomial, so minus. Now here's where you want to be very careful. You actually want to put all the terms in the second polynomial inside parentheses. Okay, so we did not have to do that when we added polynomials. Now that we're subtracting polynomials, we want to do that. So this becomes minus 2y squared plus 2xy minus 3. And here's why. You actually have to take this negative sign and distribute it to all three terms in this polynomial here. So we're going to take this negative, we're going to multiply it here, we're going to multiply it here, and we're going to multiply it here. If you do not do that, you'll get this question wrong 100% of the time. All right, so again, we're not touching this first polynomial just yet, so let's just copy it down as is. 5y squared plus 2xy minus 3. Now let's distribute this negative. Negative times positive 2y squared. A negative times a positive is a negative, so this becomes minus 2y squared. A negative times a positive 2xy is going to be negative 2xy. And finally, we have a negative times a negative 3. A negative times a negative is going to be positive, so that's going to be positive 3. All right, so now we're just combining like terms, and we already know how to do that. Let's start all the way over here on the left. Okay, we have 5y squared. Our letter variable is y, and it's raised to the second power. So let's scan this expression for the letter variable y raised to the second power. It's right there. 5y squared minus 2y squared is simply 3y squared. And since we combine those, let's go ahead and cross them out. Next, we have 2xy. So we're looking for the letter variables x and y, both raised to the first power. And as you can see, that's right there. 2xy minus 2xy is 0, so those go away. Then finally, we have negative 3 and positive 3. Negative 3 plus 3 is 0. So we are done. All right, so that's that one. Again, I can't stress this enough. As a matter of fact, I put this on my reference sheet, which you can download for free from my website, asvabapp.com. When you subtract polynomials, you have to put the one that you're subtracting by in parentheses, and then you have to distribute that negative to all the terms inside parentheses. Okay? If you don't do that, you won't get it right. But that said, let's go ahead and move on to something else now. All right, so let's move on to the third topic in this video. Notably, let's take a look at how to multiply polynomials. So when you're multiplying polynomials, the thing you want to keep in mind is the distributive property. And I like to think of the distributive property like this. You take all the terms in your first polynomial and you multiply them by all the terms in your second polynomial. So with that definition in mind, let's take a look at our first example here. Again, we have 2 times x plus 3y. So let me go ahead and copy that off to the side. We have 2 times x plus 3y. Now this 2 is actually our first polynomial. Again, the distributive property says take your first polynomial and multiply it by all the terms in your second polynomial. Well, this x plus 3y is the terms in our second polynomial. So according to the distributive property, we're going to do 2 times x as well as 2 times 3y. 2 times x is 2x, and 2 times 3y is simply 6y. All right, so we just multiplied those two things together. Let's go ahead and take a look at number 2 now. Again, distributive property says take all the terms in your first polynomial and multiply them by all the terms in the second polynomial. All right, so with that in mind, let's take a look at this one. We have 3x minus 4 and 5x minus 2. Again, 3x minus 4 is our first polynomial, and 5x minus 2 is our second polynomial. So again, according to the distributive property, we're going to take this 3x, we're going to multiply it here as well as here. Then we're going to take negative 4, and we're going to multiply it here as well as here. All right, so let's go ahead and do that. 3x times 5x is going to be 15x squared. 3x times negative 2 is going to be negative 6x. Negative 4 times 5x is going to be negative 20x. And then negative 4 times negative 2 is going to be plus 8. And whenever possible, you want to combine your like terms. There is no letter variable x raised to the second power, except 4 and 15x squared. So we're just going to copy that one down as is. Negative 6x and negative 20x are like terms, so we'll combine them to be negative 26x and then plus 8. All right, so when we multiplied 3x minus 4 and 5x minus 2 together, our result was 15x squared minus 26x plus 8. And that's all there is to multiplying polynomials. All right, so now that we've discussed like terms and polynomials, let's go ahead and start talking about lines. More specifically, let's work on finding the slope of a line. And if you go to my website, asvabapp.com, you can download a copy of my free reference sheet. And you should notice that the very first formula on the very first page is in regard to finding the slope of a line. And that formula is this: m equals y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are points on the line. So again, we can express those like this. This would be x1, y1, and this would be x2, y2. All right, so with that in mind, let's take a look at this first question here. We want to find the slope of a line that passes through the points negative 20, negative 4, and negative 12, negative 10. Well, the first thing you should realize is that you can label these. Again, this would be x1, which would make this y1. Therefore, this is x2, and that makes this y2. Now that you've labeled your points, you can simply plug the values in to the slope formula, which is m equals y2 minus y1 over x2 minus x1. Well, what is y2? It's right here. It's negative 10. What is y1? It's right there. It's negative 4. What is x2? It's right there. It's negative 12. And what is x1? It's right there. It's negative 20. So these minuses become plus. So negative 10 minus negative 4 simply becomes negative 10 plus 4. Likewise, negative 12 minus negative 20 becomes negative 12 plus 20. All right, so let's go ahead and do that simple arithmetic there. Negative 10 plus 4 is negative 6. And I would read this as 20 minus 12, which is 8, of course. And we can actually simplify this fraction by dividing 6 as well as 8 by 2. 6 divided by 2, of course, is 3, and 8 divided by 2 is 4. So the slope of the line that passes through the points negative 24 as well as negative 12, negative 10 is negative 3/4. Okay? And since our slope is negative, we know our line is decreasing as it goes from left to right. Let's take a look at number 2 now. Again, we're trying to find the slope of a line that passes through the 2 points, negative 3, 1, as well as negative 17, 2. Again, I like to start these problems by labeling the values of my points accordingly. I know this is x1, which makes this y1. This is x2, and that makes that y2. Then I'm going to jot down the slope formula. Again, that's m equals y2 minus y1 over x2 minus x1. And we already know what those values are since we labeled those values. So let's go ahead and plug them in. Again, y2 is right there. It's 2. So this becomes 2 minus y1. It's right there. It's 1 over x2. It's right there. Negative 17 minus x1. It's right there. It's negative 3. All right, let's work this out. 2 minus 1 is just 1. Again, we have negative 17 minus negative 3. These minus becomes plus. Negative 17 plus 3, of course, is negative 14. All right, so this is negative 1 over 14. In other words, the slope of the line that passes through the points negative 3, 1, and negative 17, 2 is negative 1 over 14. All right, so that's that one. All right, so occasionally you'll be given an equation of a line and you'll be asked to identify its slope. So if you go to my website, asvabapp.com, and download a copy of my reference sheet, you should see that on the very first page, I have a box called Equations of Lines. And in that box, there are 3 forms for an equation of a line. And the form I want to talk about now is called the slope-intercept form. And that's written like this: y equals mx plus b, where m is our slope and b is our y-intercept. Well, as you can see, number 3 is written in slope-intercept form. So all we do is have to figure out what m is to determine what the slope of y equals negative x plus 2 is. Let me go ahead and write this down here. Y equals negative x plus 2. Well, in algebra, you typically don't express ones. And as we've seen already, we don't express exponents when they're ones. And the same is true when we have a coefficient of 1. So technically, there's a negative 1 in front of this x. And we could just go ahead and circle this m to indicate that negative 1 is going to be our slope. So our slope in this case is negative 1. And let's go ahead and do the same thing for number 4 here. Again, as we can see, the equation of this line is written in slope-intercept form. That is, it's written as y equals mx plus b, where m is our slope and b is our y-intercept. Again, here's our line, y equals negative 5x minus 1. And as we can see, this negative 5 is our slope. So we would say the slope, our m, is negative 5. All right, so that's all there is to identifying a slope when you're given a line in slope-intercept form. All right, so now that we've talked about slope, let's work on writing the equations of some lines. So first things first, I want to say this. You are going to need the slope formula to do this more often than not. So again, that's m equals y2 minus y1 over x2 minus x1. We already know what x1, y1, x2, y2 are. Those are the values from our ordered pairs. And we're also going to need to know the point slope form of a line. And the point slope form of a line is this: y minus y1 equals m times x minus x1. And we already know all of these things. Again, we already know m refers to slope, and we already know x1, y1 we get from the values of our ordered pairs. So in short, we're going to find our slope using the slope formula. And once we get our value for m, we're going to plug that into the point slope equation, as well as values from one of our ordered pairs. So it's a very simple and easy process. And in light of that, let's get started with number 1 here. To get started, I'm simply going to label the values of my ordered pairs. So this is going to be x1, y1, which makes this x2, y2. First things first, I need to figure out what the slope is of the line that passes through these 2 points. And again, we can find that using this formula, m equals y2 minus y1 over x2 minus x1. We already know what all these values are. So y2 is right there, it's 2, minus y1, it's right there, it's negative 3. x2 is right there, it's negative 1, minus x1 is negative 2. Again, these double negatives become plus. 2 plus 3 is 5. Negative 1 plus 2 is just 1. 5 over 1 is just 5. So m in this case is 5. And I'm actually going to copy this ordered pair over here. Again, that's negative 2, negative 3, and we already know that this is x1, y1. And as I mentioned previously, we're just going to plug all these things in to the point slope equation, which is this: y minus y1 equals m times x minus x1. What is y1? It's right there, it's negative 3, so this becomes y minus negative 3 equals m. It's right there, it's 5 times x minus, what is x1? It's right there, it's negative 2. Again, these double negatives become plus. So this becomes 1, or y plus 3 equals 5x plus 2. After that, we got to distribute this 5 to this x as well as to this 2. So this becomes y plus 3 equals, what's 5 times x? Well, that's 5x. 5 times 2 is 10. And again, we want to get this in slope-intercept form, which is this: y equals mx plus b. And so in other words, we want to get y by itself, and we can do that by subtracting 3 from both sides. This crosses out here, leaving you with just y on this side. So y equals 5x. 10 minus 3 is 7. All right, so the equation of the line is y equals 5x plus 7. Again, first we found the slope. Then we took the slope as well as the values for one of the ordered pairs and plugged them into the point slope equation. And then we rearranged that point slope equation to put it in slope intercept form, which is y equals mx plus b. It's a bit of a process, but nothing's too difficult. All right, so let's do another example. All right, so let's take a look at a variation of the first problem. It says, write the equation of the line that passes through the point -5, 1 and has a slope of 4/5. All right, so this one is a little bit easier because we already know what our slope is. So we know m, our slope, is 4/5. And we also have a point on the line, notably -5, 1. So let's label those values accordingly. We'll call this one x1, y1. Now that we have both those things, we can skip a few steps ahead and plug these values into the point slope equation, which again is y minus y1 equals m times x minus x1. All right. Uh, this becomes y minus, what is y1? It's right there, it's 1, so y minus 1. What is m? It's 4/5, so this is 4/5 times x minus, what is x1? It's right there, it's -5. Let's take care of these double negatives. This becomes x plus 5. All right, so let's just go ahead and quickly rewrite that. That's y minus 1 equals 4/5 x plus 5. And if you recall, the next thing we have to do is take this 4/5, distribute it here as well as here. And let me move down a little bit. So this becomes y minus 1 equals 4/5 times x is 4/5 x. And then we have 4/5 times 5. Well, let me work that off to the side. Again, we have 4/5 times 5. That is to say, we're multiplying a fraction by a whole number. Well, I could write 5 as a fraction by placing it over 1. And when you multiply fractions, you really just multiply straight across. So this becomes 4 times 5, which is 20, over 1 times 5, which is 5. 20 divided by 5 is 4. So this is 4/5 times 5, which is the same thing as 4. Again, we want to now write this in slope-intercept form. Slope-intercept form is y equals mx plus b. So we're going to add 1 to both sides to get y by itself. This crosses out here, leaving you with y equals 4/5 x plus 5. And that is the equation of our line in this case. All right, so that's how you write the equations of lines. Pretty simple and straightforward. All right, so this next topic is in regard to finding the distance between 2 points on a line. And the way we do that is by using the distance formula. The distance formula says this: d, our distance, is equal to the square root of x2 minus x1 squared. That is the horizontal difference between the 2 points on a line, plus y2 minus y1 squared. That is the vertical distance between the 2 points on a line. And as it happens, x1, y1, x2, y2 are simply values that you get from your ordered pairs. So again, this would be x1, y1, x2, y2. So let's go ahead and get started by plugging those values in accordingly. And my pen is starting to act up here a little bit. Just bear with me. What is x2? It's right there. It's -7. So this is -7 minus x1. x1's right there. It's -2 squared plus, what is y2? It's right there. It's -7 minus y1. It's right there. It's 3 squared. So let's go ahead and keep solving this. This is a double negative, so we know that's going to become positive. -7 plus 2 is going to be -5 squared plus -7 minus 3 is -10 squared. Let's keep working this out. -5 squared is 25. Again, that's the same thing as -5 times -5. Negative times a negative would be a positive. Likewise, -10 squared is the same thing as -10 times -10, which would be positive 100. So this is the square root of 125. And we got to simplify this radical now. And here's how I'm going to do it. I'm going to break it down like this. 125 is the same thing as 5 times uh, 5 times 25. Again, 25, 50, 75, 100, 125. And when you multiply two things under a radical, you can actually break them apart like this. This becomes the square root of 5 times the square root of 25. We should know that the square root of 25 is just 5. So this becomes 5 square root 5. Again, I got this 5 from the square root of 25, and then we multiplied that by the square root of 5, which we can't simplify any further. So the distance between these 2 points on a line is 5 radical 5, which is about 11.18 or somewhere around there. All right. So again, you do have to know the distance formula for the ASVAB. It's pretty easy to remember. All right, so for number 2, we're trying to find the distance between 2 points on the line. And as we can see, those 2 points are 2, -9, as well as -1, 4. To start, I'm going to go ahead and label these values accordingly. Again, I know this is going to be x1, y1. I know this is going to be x2, y2. What's more, I know that I'm going to be plugging those values into the distance formula, which is d is equal to the square root of x2 minus x1 squared. That is the horizontal distance between the 2 points on the line, plus y2 minus y1 squared. That is the vertical distance between the 2 points on the line. And we already know what those values are, so all we have to do is plug them in accordingly. What is x2? Well, that's right there. It's -1 minus x1. It's right there. It's 2. And that's going to be squared plus y2. It's right there. It's 4 minus y1. It's -9. Of course, that's going to be squared. Let's go ahead and take care of this arithmetic. Again, right here we have a double negative, so that's going to become plus. -1 minus 2 is going to be -3 squared, and 4 plus 9 is 13 squared. -3 squared is the same as -3 times -3, which is 9. And 13 squared is the same as 13 times 13, which is going to be 169. You could work that off to the side if you wanted to, but you should memorize your perfect squares. And now all we have to do is add these together. 169 plus 9 is going to be 9 plus 9 is 8, plus 1, 6 plus 1 is 7, and 1 plus nothing is 1. Square root of 178. And if I'm not mistaken, we can't simplify this anymore. So the distance between these 2 points is the square root of 178. All right, so that's that one. All right, so let's switch gears a little bit and let's talk about factoring quadratic equations. Before we do that, though, I just want to point this out. For the last 3 topics, I was talking about lines, and I mentioned that the form of a line was this: y equals mx plus b. Now, when we talk about quadratic equations, they're going to be of this form: ax squared plus bx plus c. The most notable difference between a quadratic equation and an equation of a line is the fact that a quadratic equation has one of its letter variables raised to the second power, whereas an equation of a line has all of its letter variables raised to the first power. What's more, we should realize that equations of lines just look like that, whereas quadratic equations, when you graph them, look like U's. Okay, so with that in mind, let's go ahead and work on factoring some of these. This first one says factor x squared minus 7x minus 18. So we have x squared minus 7x minus 18. So again, let me go ahead and write the general formula for a quadratic equation. We have ax squared plus bx plus c. Now, when we have nothing in front of our first term, we say that there's a leading coefficient of 1. Again, in algebra, you don't express 1 times a letter variable, so we know there's a 1 there. And whenever you have a 1 in front of your leading term, it can always be factored like this more often than not, just x times x. And then you just have to fill in 2 values here. And the way you do that is like this. You're looking for 2 terms that multiply to negative 18 and add to negative 7. All right, so again, we're looking for 2 terms that multiply to negative 18 but add to negative 7. Well, what about negative 9 and positive 2? Negative 9 times positive 2 is negative 18. Negative 9 plus 2 is negative 7. And just like that, we factored this one. All right. All right, so for number 2, we're trying to factor x squared minus 16x plus 63. And since we have a leading coefficient of 1 here, chances are we're going to be able to factor this quadratic equation like this. And now we're looking for 2 terms that multiply to positive 63 but add to negative 16. Well, what about negative 9 and negative 7? Negative 9 times negative 7 is positive 63. Negative 9 plus negative 7 is negative 16. Okay, so we just went ahead and factored that quadratic equation. All right, let's go ahead and look at number 3 now. So we're still trying to factor a quadratic equation. And for number 3, we have the equation 2x squared plus 17x plus 21. All right, so previously we saw quadratic equations that had leading coefficients of 1. In this case, our quadratic equation has a leading coefficient of 2. And because of that, we actually have to use a more advanced factoring technique in order to factor this one. Again, we're still working with quadratic equation, and all quadratic equations are going to be of the form ax squared plus bx plus c. So you should see that a is 2, b is 17, and c is 21. That's going to be important because I'm actually going to use what's called the Australian method to factor this one pretty quickly. And the Australian method says take a and multiply it by c. So we're going to take 2 and multiply it by 21. 2 times 21 is going to be 42. Identify b. We know b is right here at 17. Then we're looking for 2 factors of 42 that add to 17. So at first glance, you might be saying, well, 6 and 7. Well, 6 times 7 does equal 42, but 6 plus 7 is not 17. The 2 factors that are going to work are going to be 14 and 3. 14 times 3 is 42. 14 plus 3 is 17. Okay? So now that we've identified those 2 factors, what we're going to do is we're going to use them to rewrite this middle term so that we can ultimately factor this one by grouping. And we want to rewrite this middle term using both of these factors such that it's very easy to factor by grouping. So you can either decide to put the 3 first or the 14 first. And in this case, I think we're going to put the 14 first. So this is going to be rewritten as 2x squared plus 14x. Again, I grabbed that 14 from here, plus 3x plus 21. So you can see I rewrote 17x to be 14x plus 3x. All right, so now we're going to attempt to factor this by grouping. So when you factor by grouping, you kind of imagine that you're working on uh, two parts at once. You work on 2x squared plus 14x. You try to factor common terms out of there. And then you try to factor common terms out of 3x plus 21. So let's get started with 2x squared plus 14x. What can I factor out of that? Well, I can factor out 2x. This becomes x plus 7. And then when I factor a common term out of 3x plus 21, I want it to match x plus 7 in parentheses. So I'm going to factor out a 3. That's going to leave me with x plus 7. All right, so we're almost there. And again, this is plus because this was plus here. Now we're going to combine these two into one of our answers, 2x plus 3. And then we're just going to bring down one of the x plus 7s that repeat. So that's going to be x plus 7. And just like that, we factored this one using the Australian method. And if you wanted to, you could expand this using the distributive property to check your work. Again, we got 2x. We're going to multiply that here and here. We got 3, so we're going to multiply that here and here. 2x times x is 2x squared. 2x times 7 is going to be plus 14x. 3 times x is plus 3x, and 3 times 7 is plus 21. Combine like terms, this becomes 2x squared plus 14x, and 3x is going to be 17x plus 21. So you can see that this does in fact match that, which means we factored it correctly. Okay? The Australian method does take some work to get good at, but as you can see, it helps you solve these pretty quickly and accurately. All right, so that's factoring. Not all the factoring problems on the ASVAB will be this difficult. That said, you should expect some difficult factoring problems if you're doing really well on the test. All right, so that's that one. Let's go ahead and move on. All right, so our next topic is solving equations. So that means we're going to try to get our letter variables by themselves ultimately. So again, if we're dealing with x, our goal is to get x equal to something by itself. So let's go ahead and get started by looking at number 1. We have x minus 4 equals 7. And not surprisingly, I'm going to write this one off to the side. X minus 4 equals 7. Our goal is to get x equal to something by itself. So in this case, this is a one-step equation because we just have to add 4 to both sides. This crosses out, leaving you with x equals 7 plus 4, which is going to be 11. All right. And yes, questions on the ASVAB do get that simple. Number 2 says x over 3 equals negative 9. So we have x over 3 equals negative 9. And we want to solve for x. So ultimately, we're going to try to get x equal to something by itself like that. Well, as I've said in this video multiple times already, technically there's a 1 in front of this x. We just don't express it in algebra. That said, in this case, it's helpful to express it because again, I can express this as 1 over 3 times x like that equals negative 9. And now I can easily get rid of this 1/3 in front of this x by multiplying 1/3 by its reciprocal, which is 3 over 1. This will cross out here and here, leaving you with just x over there. And let's take a look at what we have here. I'm going to write this off to the side. We have negative 9 times 3 over 1. Well, what is 3 divided by 1, or 3 over 1? 3 over 1 is just 3, so this is negative 9 times 3. And negative 9 times 3, you should know, is negative 27. So x in this case is negative 27. And if you plug in negative 27 for x right here, you should see that this makes a true statement. So we have negative 27 over 3 equals negative 9. Negative 27 divided by 3 is negative 9. Does negative 9 equal negative 9? It does. That's a true statement. So we do know that x, in fact, does equal negative 27. All right, so that's that one. Let's go ahead and work on number 3, which is slightly more challenging. We have 2 over 8 plus 3 over 4 equals W over 5. All right, so the first thing I want to do is I want to combine 2 over 8 and 3 over 4 into one term. Again, we're just adding two fractions there, so we can easily combine those. And as I've mentioned in this video already, when you add fractions, they have to have the same bases or denominators. In this case, we have a denominator of 8 and a denominator of 4. So we want to rewrite either one or both of these fractions such that they have the same denominator. Well, what's the common denominator between 8 and 4? That's going to be 8. So we're going to rewrite these fractions such that they have denominators of 8. And my pen is starting to act up on me here. All right, so 2 eighths already has a denominator of 8, so we'll just go ahead and copy that one down as is. To write 4 as 8, we have to multiply it by 2. 4 times 2 is 8, and we're also going to have to do that to its numerator. 3 times 2 is 6. All right, so now we're just adding these two fractions. 2 eighths plus 6 eighths is 8 over 8 equals W over 5. My pen is starting to die on me. All right, what is 8 over 8? 8 over 8 is just 1, so this is 1 equals W over 5. And again, we can imagine that there's a 1 in front of this W, so we can actually rewrite this as 1 equals 1 over 5 W. And to clear this 1 over 5 from in front of this W, we can multiply it by its reciprocal, notably 5 over 1. And we're going to do that to both sides. This crosses out here and here, leaving you with W over there. Again, this is 5 over 1 times 1. Well, 5 over 1 is just 5. So this is 5 times 1. 5 times 1 is 5. So we can see that W equals 5 in this case. Okay? And again, we can check to see if this makes sense. When we added these two fractions, we got 8 over 8. And we know W is 5, so let's plug that in for W. That's 5 over 5. 8 over 8 is 1. 5 over 5 is 1. Does 1 equal 1? It does. So we know, in fact, W is 5. We solved that one correctly. All right, so number 4 says x plus 4 over 7 equals 3 over 7. To start this one, I'm going to copy the problem here. Again, we have x plus 4 over 7 equals 3 over 7. So clearly, the first thing we want to do is make an effort to get rid of 7 from the denominator. And one way we can do that is to multiply both sides by 7 over 1. And you can solve this pretty quickly. But that said, in case you haven't worked with fractions in a long time, let me work these off to the side. Again, right here we have 3 over 7 times 7 over 1. So let's see what that looks like off to the side. Again, 3 over 7 times 7 over 1. As you can see, we're just multiplying two fractions together. And when you multiply fractions together, you just multiply straight across. So this becomes 3 times 7, which is 21, over 1 times 7, which is 7. 21 divided by 7 is 3. So that's the long way to work something like that out. But more often than not, you should be able to work on these mentally. And you would say 7 goes into 7 one time, and 7 goes into 7 one time. So this becomes 3 times 1, which is 3, over 1 times 1. So that's 3 over 1. Anything over 1 is just itself. So that would just be 3. Okay? We're going to take that approach here. Again, we're just going to cross out our corresponding 7s, which is ultimately going to leave us with x plus 4 over 1. Anything divided by 1 is just itself. So x plus 4 divided by 1 is just x plus 4. Now we're just solving for x, which means we're going to try to get x by itself by subtracting 4 from both sides. This crosses out, leaving us with x equals 3 minus 4, which is negative 1. All right, so in this case, it might be helpful to quickly check your answer, and you can do that by plugging in negative 1 for x in our original equation. So this becomes negative 1 plus 4 over 7 equals 3 over 7. And if this turns out to be a true mathematical statement, then we know we did our work correctly. Negative 1 plus 4 is 3, so this is 3 over 7 equals 3 over 7, and that is in fact a true statement. So therefore, we know x is in fact negative 1. All right, so that's that one. Let's take a look at number 5 here. For number 5, I'm going to work that off to the side here. We have 3 to the x equals 81. So we're looking for a value of x that makes 3 raised to the power of x equal 81. Well, let's think about it this way. What is 3 squared? 3 squared is the same as 3 times 3, and 3 times 3 is 9. What is 3 to the third? Well, 3 to the third is the same as 3 times 3 times 3. And let's use some mental math skills here. 3 times 3 is 9, times 3 is 27. What about 3 to the fourth? Let's work that out. Again, that's 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And what is 27 times 3? Well, 7 times 3 is 21, so drop down a 1, carry a 2. 2 times 3 is 6, plus 2 is 8, so this is 81. So as we can see, when x is 4, we know that we will have 81 as a result. So in this case, x is 4. All right, so that's that one. Those problems are a little bit tricky, but once you see enough of them, they become very easy to work out. So that said, let's go ahead and move on to our next topic in this video. All right, so our next topic is about solving system of equations. And while there are many methods to solve systems of equations, the two you learn about in Algebra 1 as well as Algebra 2 are the substitution method as well as the elimination method. Personally, I prefer using the elimination method, so that's what I'm going to show you how to use in this video. The elimination method, in short, says this: multiply either one or both of your original equations by a constant, such that when you add the two equations together, one of your letter variables, that is x or y, is eliminated. So with that in mind, let's take a look at how we're going to solve this first one. We have x plus 7y equals 0. Then we have 2x minus 8y equals 22. Again, according to the elimination method, we're going to multiply either one or both of our original equations by a constant such that when we add them together, one of the letter variables is eliminated. Well, it should be pretty clear that we can multiply this top equation by a constant of negative 2. So in other words, we're going to take this negative 2 and we're going to distribute it here, here, and then finally here. And as you should see, when I do negative 2 times x, that's going to be negative 2x. And when I add negative 2x to positive 2x, the x variable goes away since that would be 0. All right, so let's distribute this negative 2. Negative 2 times x, as I just said, is negative 2x. Negative 2 times positive 7y is going to be negative 14y. And negative 2 times 0 is just 0. Again, anything times 0 is 0. And we're just going to copy this second equation under this top equation. So that's going to be 2x minus 8y equals 22. And now we're going to add these two equations together. And negative 2x plus 2x is 0. So that variable x is eliminated, okay? Negative 14y minus 8y is going to be negative 22y. And of course, we have 0 plus 22, which is just 22. Again, our goal is to solve for a y at this point, so we're going to divide both sides by negative 22 to get y by itself. This crosses out here, leaving you with just y on this side. 22 divided by negative 22 is going to be negative 1. All right, so we found that y is equal to negative 1. Now, according to the elimination method, once you find the value of one of the variables, you plug that into either of the two original equations, which will enable you to quickly solve for the other variable. So here are our two original equations. And as it happens, I'm going to plug in negative 1 into this top equation. So the top equation was x plus 7y equals 0. We now know that y is negative 1, so let's take negative 1 and plug it in right there. This becomes x plus 7 times negative 1 equals 0. Let's keep working this out. This is x plus 7 times negative 1 is going to be, and let me get rid of that positive sign there. 7 times negative 1 is negative 7. Of course, this equals 0. And now to solve for x, we'll go ahead and add 7 to both sides. This will cross out, leaving you with x equals 7. All right, so our answer to this one is x equals 7, y equals negative 1. Occasionally, your answer will be expressed as an ordered pair, in which case that would look like this: 7, negative 1. Of course, you can always plug these values into your original equation to ensure that they make true mathematical statements, which means that you did in fact solve the system correctly. So let's go ahead and do that. Again, our first equation was x plus 7y equals 0. We now know that x is 7 and y is negative 1, so let's plug those in. This becomes 7 plus 7 times negative 1 equals 0. This becomes 7 minus 7 equals 0. 7 minus 7 is 0. Does 0 equal 0? It does. So these two values make a true mathematical statement when we plug them into the top equation. Now, plugging them into the second equation is going to be a little bit more difficult, but I think it's worth taking a look at. Again, this second equation was 2x minus 8y equals 22. Again, we know x is 7 and y is negative 1, so let's plug those in accordingly. This becomes 2 times 7 minus 8 times negative 1, and this has to equal 22 to be a true mathematical statement. 2 times 7 is 14, and negative 8 times negative 1 is going to be positive 8 equals 22. 14 plus 8 is 22, so this is 22 equals 22, which is a true mathematical statement. So we checked both of these values by plugging them into both of our original equations and found that they made true mathematical statements, so I'm 100% confident that we solved this system correctly. Again, over here we just checked our answer on the ASVAB, especially if you're taking the computer adaptive ASVAB at MEPS. The test is going to be timed, so I don't recommend that you spend the time checking your answer like I did over here. I'm just doing that to illustrate that you can do it pretty easily. All right, so that's one system of equations there solved. All right, so we're running out of space here, so let me try to box this off as best I can. But again, we're still working on solving a system of equations. And as you can see, for number 2, our system of equations is 4x minus y equals 20. And then we have negative 2x minus 2y equals 10. All right, so we're still using the elimination method in an effort to solve this system of equations. which means we're either going to multiply one or both of these equations by a constant, such that when we add our two equations together, one of our letter variables is eliminated. And we should see that we can take this bottom equation and multiply it by 2, which will eliminate this 4x. Again, 2 times negative 2x is negative 4x. 4x plus negative 4x would be 0. So again, we're going to take this 2 and we're going to distribute it to all the terms in this set of parentheses down here. And we're not going to touch this top equation, so let's go ahead and copy that over here as is. That's 4x minus y equals 20. And let's go ahead and distribute this 2 now. 2 times negative 2x is negative 4x. 2 times negative 2y is negative 4y. And then 2 times 10 is 20. And again, according to the elimination method, we're going to add these two equations together now. 4x plus negative 4x is 0, so that's eliminated. That said, we have negative y plus negative 4y, which is going to be negative 5y. And 20 plus 20, of course, is 40. Again, our goal is to solve for y. So our next step is to divide both sides by negative 5. This crosses out here, leaving you with y equals 40 divided by negative 5. Again, a positive divided by a negative is going to be a negative. We should know that 40 divided by 5 is 8. So in this case, we know y is negative 8. All right, so according to the elimination method, once you solve for one of the variables, you want to plug it into either of your two original equations to solve for the other variable. So I'm going to plug it into this top equation since it looks pretty easy to work with. This top equation said x, or 4x minus y equals 20. And we now know that y is negative 8. So in place of y here, I'm going to put negative 8. This becomes 4x minus, again, y is negative 8, so this is minus negative 8 equals 20. Again, double negatives become positive, so this becomes 4x plus 8 equals 20. And again, we're solving for x, so the first thing I want to do is get this 8 to this side of the equation via subtraction. This becomes 4x equals, what is 20 minus 8? Of course, that's going to be 12. Now we're going to divide both sides by 4 to get x by itself, and that leaves us with x equals 12 divided by 4, which is 3. And my pen is starting to act up here. So the solution to this system of equations is x equals 3, y equals negative 8. Of course, when you take the ASVAB, that solution may be expressed as an ordered pair. So that would be 3, negative 8. Okay? So in a nutshell, that system of equations. Again, on my YouTube channel, I have quite a few videos as to how you can solve those, including how to use the substitution method to solve these, if that's the method you prefer. All right, so let's go ahead and move on to our next topic now. All right, so as you can see, the next topic in this video is in regard to evaluating algebraic expressions. And in short, all you're going to do is take the values you're given for letter variables, plug them into your algebraic expression, and then simplify that expression accordingly. So let's go ahead and take a look at an example of that. For this first one, we're going to be evaluating the algebraic expression x times y times z plus x squared minus y squared when x is 3, y is negative 4, and z is 5. All right, so not surprisingly, I'm going to go ahead and copy this expression off to the side here to get started. So we have x times y times z plus x squared minus y squared. And we're told to let x be 3, y is negative 4, and z is 5. All right, so now that I've copied this expression down, I'm simply going to replace the letter variable x in this expression with 3, the letter variable y in this expression with -4, and the letter variable z with 5. And as it happens, I like to use parentheses when I plug things in. So that's going to look like this. Again, we know x is 3, so this is going to become 3. We know y is -4, and we know z is 5 plus, again, we know x is 3, so this is 3 squared minus, and we know y is -4 squared. All right, so here's where you need to know your order of operations. Again, I remember the order of operations by using the acronym PEMDAS, or you can remember it using the mnemonic device, please excuse my dear Aunt Sally. The order of operations tells you directly how to simplify this expression here. More specifically, it says work out what's in parentheses first, if anything is in parentheses, then work on exponents next, if there are any exponents. Then you work on multiplication and division as they appear in your expression from left to right. That is to say, they're treated as equals, so you work them out from left to right. And then finally, you take care of addition and subtraction as they appear in your expression from left to right. Again, we treat those as equals. And if we scan our expression here, you can see that nothing's in parentheses to work out. So we'll go ahead and cross that out. That said, we do have exponents, notably 3 squared, as well as -4 squared. So let's go ahead and take care of that. I'm just going to copy down the rest of this expression since we're not working on anything there yet. All right, 3 squared is the same as 3 times 3. 3 times 3 is 9, so this becomes plus 9. And let's go ahead and work this off to the side since some of you will benefit from seeing it that way. This is -4 squared, which is the same thing as -4 times -4. Well, a negative times a negative is a positive, so -4 times -4 is going to be positive 16. Okay, so -4 squared is positive 16. That said, we have this negative hanging out in front of our parentheses. So this is minus 16. All right, so we took care of our exponents. Now let's move on to multiplication and division. Here we have multiplication. That is, we have 3 times -4 times 5. Then we have addition plus 9, and then subtraction minus 16. So clearly, we're going to take care of our multiplication before we even look at addition and subtraction. And we can do this all at once. As a matter of fact, this one's actually pretty easy to do mentally. We have 4 times, our -4 times 5. Again, a negative times a positive is going to be a negative. So that would be -20. And my pen is starting to die here. Just bear with me. Times times 3 plus 9 minus 16. Again, we still have this multiplication to work out. We just did 4 times 5 there, or -4 times 5. -20 times 3 is going to be -60. So this becomes -60 plus 9 minus 16. So we took care of our multiplication. And clearly, the only thing we have left is -60 plus 9, that's addition, and then 9 minus 16, that's subtraction. Again, according to the order of operations, we treat addition and subtraction as equals, and therefore, we're just going to work these out as they appear from left to right. So -60 plus 9 is going to be -51, and that's going to be minus 16. And we took care of our addition. The only thing left is -51 minus 16. Well, you can work that off to the side like this, 51 plus 16, but you know your result's going to be negative. So 6 plus 1 is 7, 5 plus 1 is 6. So this is -67. All right, so the answer to this first one is -67. Evaluating algebraic expressions takes a lot of work, and it really tests your ability to work with positive and negative numbers. So if you struggle working with positive and negative numbers, I do have a video about that topic on my channel. You should be able to find it pretty easily. That said, we got two more examples of this to work on, so hopefully you get it by then. All right, so number 2, as you can see, says evaluate the expression a to the third b squared minus b to the third when a is -2 and b is -4. So not surprisingly, I'm going to start this one by copying our expression off to the right here. Again, our expression was a to the third times b squared minus b to the third. And we're told to let a equal -2 and b be -4. So now I'm simply going to replace a in this expression with -2 and b with -4. Of course, I like using parentheses when I plug those values in, so that's what I'm going to do next. Again, a is -2, so this becomes -2 to the third times, again, b is -4, so this is -4 squared minus, again, b is -4, so this is -4 to the third. If it's helpful, you can write out your order of operations to help you simplify this expression. Again, your order of operations are best remembered by the acronym PEMDAS. You work out parentheses first, exponents next, multiplication and division as they appear in the expression from left to right, and then finally addition and subtraction as they appear in the expression from left to right. That is to say, multiplication and division are treated as equals, so you work them out from left to right. Finally, addition and subtraction are treated as equals, so you work them out as they appear in the expression from left to right. So let's quickly look through our expression here and see what we have. We have nothing in parentheses per se to work out, so there are no parentheses. That said, we have a bunch of exponents to take care of. We have -2 to the third, -4 squared, and -4 to the third. And as it happens, I'm going to work these off to the side to illustrate how these exponents affect these negative values inside parentheses. So this first one is -2 to the third. Well, that's the same thing as -2 times -2 times -2. And let's work this out step by step. -2 times -2. A negative times a negative is a positive. So -2 times -2 is +4. Then +4 times -2. A positive times a negative is going to be a negative. So that's -8. So this becomes -8. Uh, One trick you can use to determine the sign of a negative raised to a power is this. If you have a negative raised to an odd power, such as 3, 5, or 7, you know your answer is going to be negative. If you have a negative raised to an even power, such as 2, 4, and 6, your answer is going to be positive. And we're going to see that in just a minute here. So we took care of -2 to the third power. Let's go ahead and work on -4 squared now. -4 squared is the same as -4 times -4. -4 times -4, again, a negative times a negative is a positive. -4 times -4, therefore, is +16. So this becomes +16. And let's go ahead and take a look at -4 to the third power. You should know that your answer is going to be negative. You shouldn't have to work that out. And here's why. Again, we have a negative raised to an odd power. A negative raised to an odd power is going to result in a negative answer. Okay, so that said, let's work it out. We have -4 times -4 times -4. Again, we know -4 times -4 is going to be +16. And then +16 times -4, again, a positive times a negative is a negative. If you need to, you can go ahead and work it out like this. 6 times 4 is 24, carry a 2. 4 times 1 is 4, plus 2 is 6. So this is -64. All right, so this is minus -64. So we took care of our exponents. The next thing to work on in our order of operations is multiplication and division as they appear in the expression from left to right. We have negative 8 times 16 here, and then this is minus minus, so that's subtraction. So we got to take care of our multiplication before we can work on our subtraction. And I'm going to do that off to the side. Negative 8 times positive 16. That's going to result in a negative number. So 16 times 8. 8 times 6 is going to be 48. Carry a 4. 8 times 1 is 8, 9, 10, 11, 12. So that's 128. This becomes negative 128. And let's take care of this minus minus. As you've seen in this video already, minus minus becomes plus. So this is plus 64. And there's only one operation left, notably negative 128 plus 64. So I know my answer is going to be negative. And the way I'm going to solve this one is like this. 128 minus 64. But I already know my answer is going to be negative. So 8 minus 4 is 4. And 12 minus 6 is 6. So this becomes negative 64. All right, again, you have to be good with positives and negatives in order to answer these questions. I have videos in regard to adding, subtracting, multiplying, and dividing positives and negatives. So if you need more help with that, please check out my channel. For those videos, they should be pretty easy to find. All right, so as you can see, number 3 says x plus y to the third when x equals 2 and y equals 2x. So in this case, we're trying to evaluate this expression. So let's start by copying it off to the side. We have x plus y to the third. In this case, we're told x is equal to 2 and y is equal to 2. My pen's starting to act up here. Y is equal to 2x. Now, at first glance, some of you may be stumped as to how you proceed in this case. But that said, it's not as hard as you think. We know what x is, so we can plug in x pretty easily. That said, we're told y is 2x. And while you could plug in 2x in place of y, it's actually a little bit easier if you go ahead and solve this before plugging in any values. So this says y equals 2x. Well, we know x is 2, so we can take 2 and plug it in for x over here. So this becomes 2 times, what is x? It's 2. And 2 times 2 is 4. So we know x is 2 and y is 2x, which is the same thing as 4. And I find it much easier just to plug in whole values. So let's go ahead and work on doing that. This becomes, again, x is 2, 2 plus, and I like to keep things in parentheses, 4 to the third. And this one's actually pretty easy to work out. Again, if it's helpful, you can write out your order of operations, which we're going to be taking a closer look at in just a minute here. Again, according to the order of operations, we do parentheses first, exponents next, multiplication and division from left to right, addition and subtraction from left to right. There's nothing in parentheses. That said, we do have one exponent in this case, and that's 4 to the third, which is the same as 4 times 4 times 4. 4 times 4 is 16, so this becomes 16 times 4. If you can't do that mentally, you can always work it out the old-fashioned way here. 6 times 4 is 24, so drop down a 4, carry a 2. 1 times 4 is 4, plus 2 is 6, so this is 64. So this becomes 2 plus 64. 2 plus 64 is going to be 66. All right, so that's that one. I just wanted to illustrate the fact that sometimes you'll have to do some very basic algebra to figure out what one of your other letter variables is equal to before you start plugging things in. All right, so in a nutshell, that's how you evaluate algebraic expressions. It's pretty simple and straightforward, but as you saw, you really have to be good at adding, subtracting, multiply, dividing, and even raising positives and negatives to exponents in order to solve these ones accurately. All right, so that said, let's go ahead and move on to our next topic. There's only 2 questions in this next topic, and as you can see, it's called order of operations. All right, so in the previous examples, we made use of the order of operations to evaluate algebraic expressions. In these 2 examples for this topic, we're going to be using the order of operations to do the same thing, but rather than focusing on plugging in values for x and y, our focus is going to really be on applying the order of operations to simplify these expressions. And again, the order of operations is best remembered by one of 2 methods. Either you know the acronym PEMDAS, or you use the phrase, please excuse my dear Aunt Sally. And as I mentioned, the order of operations tell you exactly how to evaluate an expression in the correct way. That is to say, you work on parentheses first, if there are any, exponents next, if there are any, multiplication and division as they appear in the expression from left to right. That is to say, they have equal precedence, they're equals. And then finally, you work on addition and subtraction as they appear in the expression from left to right. Again, we treat those as equals, so we work them out from left to right. So let me copy this expression off to the side here. Again, we have 80 divided by -8 times 4. That's not an x, that's times 4, plus parentheses 3 plus 1 squared. All right, so let's get started by looking through this expression for parentheses. And in this case, we do have parentheses. Inside parentheses here, we have 3 plus 1. So we got to take care of parentheses first. And I'm just going to copy down everything else until I get to those parentheses. Of course, 3 plus 1 is 4. So that's 4 squared. So we took care of our parentheses. Next, we look for any exponents in our expression. And if we look through our expression, we can see that we have an exponent right there. So this becomes 80 divided by -8. And I strongly encourage you to copy down your expression like I'm doing and not to skip steps. Typically, when people skip steps, they get these questions wrong. So -8 times 4. And what is 4 squared? That's the same thing as 4 times 4, which is 16. So this is plus 16. So we took care of our exponents. All right, this is where things might get a little tricky for some people. But that said, let's take a look at what operations we have remaining. We have division right here, multiplication here, and addition here. Of course, we're going to do multiplication and division before our addition. And as I said, multiplication and division are treated as equals. So we work them out as they appear in the expression from left to right. So I'm going to do this division first and then this multiplication next. 80 divided by -8 is going to be -10. Again, a positive divided by a negative is a negative. So this is -10 times 4 plus 16. Okay, so we took care of our division. We still have multiplication and addition left. Of course, we're going to work out multiplication before addition. So -10 times 4 is -40 plus 16. And now we just have addition left, so let's take care of that next. And we know our result's going to be negative since our negative value is bigger than our positive value. But the way you work this out is by doing 40 minus 16. And we already know our result's negative. So 0 minus 6 we can't do. We have to borrow. This becomes 3. This becomes 10. 10 minus 6 is 4. 3 minus 1 is, and if my pen will cooperate, 2. So this is -24. All right, not too bad there, but unlike the previous problems, we actually had to make use of working out parentheses first. Otherwise, it's pretty much the same thing. All right, so we're going to be using the order of operations to simplify this expression that we have here for number 2. And if it's helpful, you can always write those order of operations out. I would strongly encourage you to write them out if you see a question like this on the test. Again, we work on parentheses first, exponents next, multiplication and division as they appear in the expression from left to right. That is to say they're treated as equals. And then we do addition and subtraction as they appear in the expression from left to right. So let's go ahead and copy our expression down. We have 49 divided by 1 divided by 7 times 6 plus -2 to the third. All right, so again, according to the order of operations, we're going to work on parentheses first. And if we look through our expression very quickly, you can see that we have something in parentheses here. 49 divided by 1 is just 49. So this becomes 49 divided by 7 times 6 plus -2 to the third. All right, so we took care of our parentheses. And next, we're going to be looking for exponents to evaluate. And as you can see, we do have an exponent here. Specifically, we have -2 to the third, which I'm going to work off to the side for you. That's the same as -2 times -2 times -2. Again, you should know right away that we have a negative raised to an odd power, so our answer is going to be negative. But that said, you can always work it out the old-fashioned way. -2 times -2 is +4. +4 times -2 is going to be -8. So this becomes 49 divided by 7 times 6. And then this is -8, so it's going to be -8. All right. So now we have 3 operations left. We have division, multiplication, and subtraction. Again, according to the order of operations, you do multiplication and division before addition and subtraction. And in addition, you do multiplication and division as they appear in the expression from left to right. That is to say, you treat them as equals. So in this case, division came before multiplication, which is no big deal. We're going to work these out from left to right. 49 divided by 7 is 7, so this is 7 times 6 minus 8. 7 times 6 is 42. This is 42 minus 8. 42 minus 8 is going to be 34, if my math's not mistaken. All right, so that is another instance of using the order of operations. All right, so that's that one. All right, so as you can see, the next topic in this video is called solving inequalities and graphing their solutions on number lines. Before we get started, I just want to mention this, even though most of you probably know this pretty well. There are 4 inequality signs. We have less than, greater than, less than or equal to, and greater than or equal to. When you graph an inequality involving the less than or greater than sign, you use an open circle on the number line. Similarly, when you graph an inequality involving a less than or equal to or a greater than or equal to on a number line, you use a closed circle to indicate that you include that value, which this equal also indicates. All right. I also want to mention this before we look at this first example. Whenever you multiply or divide across the inequality sign by a negative value, that's going to prompt you to change the direction of the inequality sign. All right, so let's take a look at a very simple example of that. We have -2x is greater than 4. All right, so we're going to be solving for x. So, of course, we would divide both sides by -2 to get rid of -2 from here. But what did I just do? I divided across this inequality sign by a negative value. So that's going to prompt me to change this from greater than to less than. So as you can see, I just changed the direction of our inequality sign. 4 divided by -2 is -2. Okay? So with those things in mind, let's go ahead and take a look at this first example. And this first example says -2x plus 1 is greater than or equal to 5. Again, we're going to be solving for x. So the first thing you want to do is subtract 1 from both sides. Again, you can add and subtract across the inequality sign all you want. It's not going to prompt you to change its direction. So this crosses out here, leaving you with negative 2x over there. It's greater than or equal to 5 minus 1 is 4. All right, so now we got to divide both sides by negative 2 to get x by itself. This crosses out. But what did I just do? I just divided across the inequality sign by a negative value. So I have to change its direction to be greater than or equal to less than or equal to. And this is 4 divided by negative 2, which is going to be negative 2. All right, so as far as graphing this goes, we're going to start at this negative 2, and we're going to put a closed circle above it, uh, since I just mentioned that in our instructions here. And we're looking for all the x values that are less than or equal to negative 2. Well, is 0 less than negative 2? No, 0 is bigger than negative 2. So we know our arrow is not going to go in this direction. What about negative 5? Is negative 5 less than negative 2? It is. So we're going to select all these values to the left. And that should be a straight line, but that is our answer. All right, so in short, that's how you solve inequalities and graph their solutions. Let's go ahead and take a look at another example. So for this one, we have negative 6 is greater than 5n plus 5 plus 4. Again, we're going to be solving for n ultimately, but let's work on simplifying this. I can combine these right here. That's 5 plus 4, which is 9. So this is negative 6 is greater than 5n plus 9. Again, our goal is to get n by itself, so we're going to subtract 9 from both sides. This crosses out, leaving you with 5n on this side. Negative 6 minus 9 is going to be negative 15. And now to get n by itself, we're going to divide both sides by 5. This crosses out, leaving you with n on this side. Negative 15 divided by 5 is negative 3. All right, so this is kind of hard to read. So I like to write it with my variable first, which means it's going to look like this. N, and we can see that n is less than. So n is less than negative 3. All right, so first things first, we're going to go to negative 3 on the number line. And since we just have a less than symbol here, we're going to use an open circle. And we're looking for all the values of n that make this statement true. So we're looking for all the values of n that are less than negative 3. Well, is 2 less than negative 3? It's not. So we know our arrow, our line, is not going to go to the right. What about negative 7? Is negative 7, when we plug it in for n, less than negative 3? It is. So we know our arrow is going to go to the left again. All right, so that's that one. Again, I have a video on how to solve inequalities and graph their solutions on number lines. So if you want more than just 2 examples, you're more than welcome to go and watch those videos, of course. All right, so let's talk about absolute value equations now. And let me just say this. Your goal is to isolate your absolute value. That is, ultimately, you want to get your absolute value equal to something by itself. Because when you do this, it's going to tell you how many solutions your equation has. So if after isolating your absolute value, it's equal to a negative value, such as negative 5, that tells you that your absolute value equation has no solution. In other words, there's nothing we can plug into this absolute value that will ever equal a negative value such as negative 5. All right, so if after isolating your absolute value, you're left with it equaling 0, that tells you that your absolute value equation has one solution. All right, and if after isolating your absolute value, it's equal to a positive value, such as positive 5, that tells you that your absolute value equation has 2 solutions. And we're going to see examples of each of these in just a few minutes. All right, but again, absolute value equal to a negative value, no solution equal to 0, one solution equal to a positive value, two solutions. All right, so with that in mind, let's go ahead and take a look at this first question now. We have the absolute value of negative 4 plus 5x equal to 16. All right, so we have our absolute value equal to a positive value. In light of that, we know there's going to be two solutions. And more specifically, our solution is going to be broken apart like this. We're going to have negative 4 plus 5x equal to 16. That's going to be one of our solutions. And then another one of our solutions is going to be negative 4 plus 5x equals negative 16. All right, so by solving each of these equations for x, we'll know what our two solutions are. So let's get started with this equation on the left here. We're going to add 4 to both sides. This crosses out, leaving you with 5x equals 16 plus 4, which is 20. Again, divide both sides by 5 now. This crosses out, leaving you with x equals 20 divided by 5, which is 4. So 4 is one of our solutions. Now let's go ahead and work over here. Let's add 4 to both sides. This crosses out, leaving you with 5x equals negative 16 plus 4 is going to be negative 12. Divide both sides by 5 now. This crosses out, so we can see x is negative 12 over 5. That's another one of our solutions. Okay, so if we plug in both of those values for x, we'll get 16 as our answer. All right, so that's an example of solving an absolute value equation in which there are two solutions. Let's take a look at number 2 now. We have absolute value of 3x plus 12 plus 7 equals 7. And as I mentioned just a few minutes ago, before we can make any determination as to how many solutions this absolute value equation has, we first have to isolate our absolute value. So first things first, we want to subtract 7 from both sides. This crosses out, leaving you with the absolute value of 3x plus 12 equals 7 minus 7, which is 0. All right, so we can see that our absolute value is set equal to 0, which means there's only going to be one solution in this case, and it's going to look like this. 3x plus 12 equals 0. Of course, we're solving for x, so let's move that 12 to the other side via subtraction. This crosses out, leaving you with 3x equals 0 minus 12 is negative 12, and divide both sides by 3 now. This crosses out, leaving you with x. A negative 12 divided by 3 is going to be negative 4. So the one solution to this absolute value equation is negative 4. All right, let's go ahead and take a look at another example now. So we have the absolute value of 3x minus 7 plus 7 equals 2. Again, before we can make any determination about the number of solutions that this absolute value equations has, we have to isolate our absolute value. So in this case, we're going to subtract 7 from both sides. This crosses out, leaving us with just the absolute value of 3x minus 7 on this side. And 2 minus 7 is negative 5. All right, so we have an absolute value equal to a negative number. And as I mentioned just a few minutes ago, this means that there is no solution to this absolute value equation. In other words, there's no value of x that we can plug in to make this a true statement. All right, so that's that one. And let's take a look at one more example here. We have the absolute value of 3x minus 7 plus 7 equals 9. All right, so let's start by isolating our absolute value, which means we're going to subtract 7 from both sides. This crosses out, leaving you with the absolute value of 3x minus 7 over there equals 9 minus 7, which is 2. All right, so we have an absolute value equal to a positive number, which should tell you that there's going to be two solutions to this absolute value equation. And let's go ahead and find those two solutions. Again, one of our solutions is going to be 3x minus 7 equals 2. And another one of our solutions is going to be 3x minus 7 equals negative 2. All right, so let's solve this equation over here. Let's add 7 to both sides. This crosses out, leaving you a 3x equals 7 plus 2 is going to be 9. Divide both sides by 3 now. This crosses out, leaving you with x equals 9 divided by 3, which is just 3. So 3 is one of our solutions. Let's go ahead and solve this equation now. We're going to add 7 to both sides. This crosses out, leaving you with 3x equals negative 2 plus 7 is going to be positive 5. Divide both sides by 3 now. This crosses out, leaving you with x equals 5 over 3. All right, so those are our two solutions, and we are done. So in short, that is how you solve absolute value equations. Isolate the absolute value. That's going to tell you how many solutions you have, and then solve accordingly. Generally, you want to learn about exponents by first reviewing the laws of exponents. If I'm not mistaken, there's uh, 5 or 6 of them. And if you look on my channel, you'll see that I have a video that's more than an hour long in regard to breaking down each of those laws of exponents. So if what I'm about to do is confusing to you, you need to watch my video called The Laws of Exponents. That said, generally the ASVAB covers very simple topics, and so I'm going to do my best to explain those laws of exponents as I work out each of these problems. So this first problem says x to the fifth times x to the third. Well, in order to use the laws of exponents to solve this one, we have to know the product rule. And the product rule says this: if you have a to the m times a to the n, you simply add their exponents such that this would become a to the m plus n. Well, as you can see, these both have to have the same base of a. Well, in this case, we have a base of x, which is the same. So to solve this one, we'll just write down our base of x, and then we'll add their exponents. So that will be 5 plus 3. Of course, 5 plus 3 is 8, so this becomes x to the 8th. All right, so that's that one. Again, we use the product rule to figure that one out. That's one of the laws of exponents. Let's take a look at number 2 now. All right, so number 2 says 6x to the 5th over 2x squared. And in order to simplify this one, we're going to have to make use of the quotient rule. And the quotient rule says this: if you have a to the m over a to the n, you simply subtract those exponents. So this becomes a to the m minus n. And as you can see, that's more or less what we have with our x's here. So x to the 5 over x to the 2, we'll simply subtract those exponents. But that said, before we can do that, we have to deal with this 6 over 2. Well, what is 6 over 2? 6 divided by 2 is 3. Now let's address these exponents. Again, we're going to write x here, and then we're going to subtract our exponents, so that's going to be 5 minus 2. So this becomes 3x. 5 minus 2 is 3, so this is 3x to the third. All right, so we use the quotient rule to simplify that one. All right, so let's look at number 3 now. As you can see, it says parentheses x squared y, and this is all raised to the 4th power. So in order to simplify this one, we're going to have to make use of the so-called power rule. And the power rule says this: if you have a to the m power, and that's all raised to the n power, that's the same as having a to the m times n. Okay? So that's more or less what we have here. That said, we have to realize a few things before we get started. First, as I've mentioned in this video several times already, we don't express powers of 1. So I know that this y is raised to the first power. Okay? Next, we're going to have to apply this power rule to both x and y individually. So let's go ahead and do that. This becomes x. Again, we're going to be multiplying our exponents. So this is going to become 2 times 4, y, 1 times 4. And that's actually pretty easy to work out. This becomes x. 2 times 4 is 8. Y, 1 times 4 is 4. All right, so we solved that one using the power rule. So let's go ahead and move on now. All right, so number 4 here says x squared y to the 5th, so that's x squared y to the 5th over x y to the 4th. So we're going to use the quotient rule to simplify this one. And in case you forgot, the quotient rule says this. If we have a to the m over a to the n, we simply subtract our exponents to be a to the m minus n. And that's what we have here, but we are going to use 2 iterations of the quotient rule, one for x and one for y. And again, if it's helpful, you can express that one there. So this is going to become x. What's the quotient rule say? It says subtract our exponents, so this is going to be 2 minus 1. And again, for y's, what's the quotient rule say? It says subtract exponents, so this is 5 minus 4. Let's keep working this out. This becomes x. 2 minus 1 is 1, so we're not going to express that 1. And then 5 minus 4 is 1. So this simplifies simply to x, y. All right, so that's that one. And then finally, number 5 says 8 to the 0 power. And this is one of the laws of exponents that you just have to memorize. Anything raised to the 0 power is always 1. All right, so that's that one. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Let me say this. On the homepage of my YouTube channel, you can find a playlist called Algebra on the ASVAB. And in that playlist, there are videos in which I work out all of these topics in much greater detail. So if as you watch this video, you struggled with any of these topics, check out that playlist, and there you can watch hour-long videos about each and every one of these topics. So all that being said, you can support my channel by subscribing to it. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.